phenomenon in larger in this way, and the smaller scale in this way to find some secret. And finally, we expect some connection between small and large scale eventually. Okay, what is the current status of our understanding of the material or some hierarchy? So in some animal or something, some material is made from the, for example, the water, some material. And this material is made from the molecules like hydrogen, water molecules. And these, for example, water molecules is composed from the oxygen and the hydrogen atoms. And finally, we know these atomic atoms is composed from these quarks and leptons, mainly up and down and electrons, but we know there are 16 quark, lepton, and bosons. And finally, we found Higgs boson last year, and but we don't know much about this one. So we'd like to know who is this boson. And let's think about how to reach beyond the known scale. So anyway, we have to find a new phenomenon which cannot be understood with the current lemma. That is we want to understand the secret of nature. And the big suggestion here is a big suggestion from quantum field theory, because a atom may contain unknown particles. Because of the some of the relation between the energy and the time, this creation and annihilation phenomenon is allowed according to the field quantum field theory. That means unknown very heavy particles are created and annihilated in short time everywhere in the world. So here. And once we give some energy to the vacuum, these unknown particles will be realized. That means we can observe. So give some large energy to the vacuum, some unknown particle will be observed. That is one way to reach unknown phenomena. And another example can be found in the history of the discovering the nucleus. So according to quantum field quantum theory, spatial and momentum relation in this by the Heisenberg simulation. And nucleus is discovered by the Rutherford with alpha particle scattering like this. So sometimes he observed some large angular scattered alpha particle from the thin gold field. So that means in this case, the high momentum or small spatial resolution of alpha particle is essential. For example, if we use visible light instead of alpha particle, we cannot see this nucleus. We see only some continuous object like that. So this case, high momentum of alpha particle is very important to observe the nucleus. So now we know observing the new nature with higher energy would cause new phenomena. So this observing higher energy phenomena will open new area of the universe to understand the physics. And the accelerator is a powerful tool to reach such region because we can increase the energy of the particle by acceleration. And the accelerator can boost up only charged particles with electric field like that. That probably means the energy boost is equal to the Lorentz force. But by looking at these terms, the second term is always zero. That means we can accelerate only charged and charged particle with electric field. So journey to the new frontier is supported by this very simple principle. So by using the accelerator. And by taking a look at the history of the of accelerator, you can find a very rapid progress on the energy in time from 1930 to 2010, something like that. So maybe you can call this is a movement law in accelerator field. But anyway, if you take a look carefully, there are several different types of accelerator you can find. And for example, one type of accelerator cannot make such big progress on the energy gain. But sometimes people investigate, invent a new way to accelerate particle with new method. As a result of these many inventions on the accelerator machine, this rapid progress is kept by these new inventions. So that means that it looks like a multi-stage rocket. So one booster can go to only up to this point, but the next boost up to that point, and so on. So as a conclusion of this historical view, we need evolution, continuous evolution to keep this rapid progress on the accelerator energy. And one of them, collider is a very big invention to reach the higher accelerated energy, because center of mass energy depends on the frame, and even the beam energy is same. So by comparing these fixed target experiment and collider experiment, the center of mass energy is scaled to the square root of the beam energy in case of the fixed target. But in collider case, this center of mass energy is scaled to the just linear twice of the beam energy. That means this collider has a big advantage to reach a higher energy than fixed target experiment. So that is my intention, to reach higher energy. So collider is very useful to reach higher energy. So many colliders has been built up to this point. So these all of them are colliders. This is an energy, beam energy, and this is constructed time. And the history of collider is actually the history of high energy peaks in the last half of the 20th century. So you can find various famous machines to develop some model of physics. Chain left is the last one, but they are linked collider except one CLC. Other colliders based on the linked collider, something like that. Two particles are circulated in the ring orbit and collide at some point, maybe several. In linear collider case, the particle are accelerated to some point and collide at once at the center of the accelerator. So all these accelerators is ring collider except one. I will explain why these most of them are. Anyway, luminosity is the essential for colliders because event rate is the mean performance of the collider. So we want many events, as many as possible. That is what we want. And actually the event rate is the product of the luminosity and the cross-section, like that. And the cross-section is the effective area for some interaction. For example, if these two particles are approach to the close enough to make some interaction, this area is considered the cross-section. But this cross-section is determined by the physics law and then determined by nature. That means this number is not overlap. We cannot change. So this cross-section is determined by nature. On the other hand, The luminosity is the particle flow rate is like that proportional to the repetition of the crossing interaction of the bunch and the number of particles in the bunch, and also the interaction area inversely proportional to the interaction area. Then this number is popular. So if we increase the repetition rate of the collision, and also if we can increase the number of particles in the bunch, or if we decrease the spot size on the interaction point, we can increase the luminosity. So luminosity is a very actually the luminosity shows the performance of the collider. So we want large luminosity as possible.